Okay, guys, this is 9.4, objective 2. The last video for this set of notes for this week.
This segment, we will talk about systems of linear inequalities. Now, by the way, what do we mean by a system of linear inequalities? Recall that a system of linear equations consisted of two or more equations. So a system of linear inequalities consists of two or more linear inequalities. This is an example of a system of linear inequalities. We'd like to graph the solutions of this system. What consists of a solution of a system of linear inequalities? It is an ordered pair solution that satisfies both inequalities in the system. So, how will we proceed? Let's graph the first inequality in this system. Then we'll graph the second inequality in the system. Then any inequalities in the intersection of these solution regions will be solutions of both inequalities and will be in the solution region for the system. So let's begin. Let's just graph x greater than or equal to 3y. How do we graph x greater than or equal to 3y? We begin by looking at the related equation, x equals 3y. Let's find some ordered pair solutions, draw in the boundary line, and go from there. For example, if y is 0, x is 3 times 0, or 0. If y is 1, x is 3 times 1, or 3. And if y is, say, negative 1, x is 3 times negative 1, or negative 3. So let's now plot those points. 0, 0, 3, 1, 3, 1, and negative 3, negative 1. Now, do I draw in a solid or dashed line? Because it's greater than or equal to, I draw in a solid line. So let's draw a solid line. And then what is left in graphing this first linear inequality in two variables? What's left is that we need to shade one side or the other of this plane, of this line. Remember, the line is called a boundary line. Now, how do we decide what side of this line to shade for just the first inequality? We find a test point and we check the test point. So let's find a test point, say 2, 2, right here. And let's check it in the inequality. Let x be 2, let y be 2. If x is 2, is that greater than or equal to 3 times 2, or 6? Well, is 2 greater than or equal to 6? The answer is no. So where do we shade? We shade below the line. So let's shade below the line. And this was my test point. I'll take that off. And I'll take off finding the boundary line. Now let's shade below this line. What have I just graphed? I have just graphed the solutions to the first inequality in our system, and that only. Now we've got to graph the second inequality in our system. X plus 3y is less than or equal to 6. How do we proceed? Well, we first look at the equation. So that is x plus 3y is equal to 6. And let's find some ordered pair solutions. What about, say, if x is 0? If x is 0, y must be 2. And then what if y is 0? If y is 0, x is 6. And I'll let you find a third checkpoint, but I'll use these points. 0, 2.
I'm making the recording, okay?
And 6, 0. Concentrate on those 2 points only. We are right now about to draw the boundary line for the second inequality. So let's draw that boundary line. Do I draw in a solid or a dashed boundary line? I draw in a solid boundary line. There are my 2 points. And let's draw that boundary line in.
No, it's fine. We'll just have 300 this week.
Concentrate on this boundary line only and the second inequality only. What's left to graphing that second inequality? It is to choose a test point and then check it in the inequality. So concentrate on this line only. I'll choose 0, 0 as my test point. If x is 0 and y is 0, is this true or false? Well, that's a true statement. So where do I shade? I shade below this boundary line. So I'll shade below that boundary line. And I've just finished graphing the second inequality. Now, you need to decide where is the solution region for this system. The solution region for this system is where these two solution regions for each of the inequalities, where they intersect. So where do we have intersecting lines? Certainly not here in this region. And if you look at this V-shape region, there's only been one shading occur here. If you look at this V-shape region, only one shading occurring there. Where is the intersection? I'm going to shade it in heavily so you can see it. It's right here where they intersect. If you take any point in this region, look at its corresponding ordered pair, it will not only satisfy this inequality, but this inequality. So this is the solution region for that system of linear inequalities. Let's look at the following. Graphing the solution of a system of linear inequalities. Step 1, graph each inequality in the system on the same set of axes. Step 2, the solutions of the system are the points common to the graphs of all the inequalities in the system. Let's look at this system of linear inequalities. I'd like to graph the solutions to this system. To do so, we'll graph.
Okay, guys, I want you to practice this one on your own. First, you need to graph the y is greater than or equal to 1. Then you need to graph x is less than negative 13. Then you need to figure out where the areas or the regions that you shade intersect, and that's your solution for the system. Okay. Let me know if you have any questions, and we go over it in class.